Hello, I'm Robert Morrison, and today we're going to take a look at conservation of energy. This lab write-up comes from our Physics Through Inquiry manual. To do this lab, we're going to need a few items. We're going to need a rod stand, we're going to need a pass track, we're going to need a clamp for the pass track, we're going to need a motion sensor, an angle indicator, a pass car, an end stop, and an interface for collecting data. So let's take a look at the physical setup, and then we'll take a look at the data and some of the analysis. I'm going to connect my pass track to my rod stand using the clamp. It fits right in the rail here on the side, slides into place, and then locks down using the nut. I'm going to place that on the rod stand here and give it a pretty good angle and set it into position. At the far end of the track, I'm going to mount the end stop. I'm going to try and get this as close to the end of the track as I can. Again, I'm mounting that into the rail and locking it into place. And then with the cart, I'm going to extend the plunger, and I'm going to set it on the track against the end stop. And we'll see why that is in just a second. I'm going to take my motion sensor, and I'm going to connect it to the end of the track. Fortunately, being a Pasco motion sensor and a Pasco track, it snaps right in. And I'm going to make sure that it's pointing directly at my cart. I want to make sure it's facing the face here. And that I have it in the cart position on the switch. So that's all set. That way I'm not looking at any other thing in the room, the rod stand, the computer, any of that stuff. Then I'm going to connect that to my interface. Okay, that is pretty much the physical setup of the lab. I'm then going to measure the angle of the track. I'm using a Pasco angle indicator. This is really useful when you're doing it with the track. If I wanted to, I could mount it to the track. If I was looking at multiple angles, that lets me measure the angle from the same point each time. But since I'm just going to be looking at this angle once, I'm going to go ahead and set it on the track, take a look at that angle, and record that for later. Okay, I'm pretty much ready to start collecting data. I'm going to collect the first run with the cart in position. I want to do that because I want to look at the initial position of the cart just as it's leaving the end stop here. So I'm going to collect that first run. That ticking indicates that the motion sensor is functioning. So I'm getting that initial distance to the cart. And I'm going to take about 10-15 seconds of data, and then I'm going to go ahead and stop. So now I have my initial position. Now I'm going to go ahead and take my cart, and I'm going to press the plunger into place, make sure it's locked, and set it once again in front of the end stop. And we're good to go. I like to use an object to launch the cart. This gives us a little crisper launch each time. I'm just using a mounting bracket for the track here. Ruler works really well too. So I'm going to go ahead and start collecting data. And then I'm going to launch the cart. I'm going to let that bounce a couple times because one of the things we're going to discuss is loss of energy as one of the factors that affects the accuracy of the lab. So I'm going to go ahead and hit the stop button. And we're going to go ahead and do some analysis. And that's all there is to the data collection. Okay. On the analysis side, I'm looking at a graph of position versus time. And I'm going to be looking at the value of position from the initial position, that first run, to the first peak in that position versus time graph. So I'm going to extend that a little bit. You also notice that we've been collecting data at 20 samples per second. The default for the sensor is 10 samples a second, so we did adjust that earlier. Now I'm going to be looking at the difference from the initial position to the final position. So let's go ahead and look at the select tool. And I'm going to select above that point and below that point so I can get a range of data, and I can adjust that until I have just the points that I'm interested in. And once I have those points in the selection, I'm going to go ahead and hit OK. And so what I'm looking at is the final and initial position because I want to look at the difference. To do that, I'm going to use one of the tools I have here, the coordinate tool. And I'm going to look at the difference between the initial and the final. So I'm interested in the y difference here, so dy. And that is 0.23 meters. Excellent. And so that's going to be the distance that the cart traveled up the track. That's going to help me calculate that final height so I can find the potential energy, the maximum potential energy of the system. And I'm going to look at a second graph, which is the velocity of the cart on the track. And that was recorded right alongside the position. And I'm going to be looking at the initial velocity. That's the velocity just as the cart was leaving the track. So that's the maximum velocity down here. So I just need the value for that point. So I'm going to once again bring up a palette. I'm going to use the selection tool. I'm going to highlight the point that I'm interested in. And I'm going to say OK. And I'm just going to get the coordinates for that point. So the y value there is the maximum velocity of the cart. OK. So now that we have what we need to calculate the maximum kinetic energy at the bottom of the track and the maximum potential energy at the top of the arc, and we can compare those two things and find out if energy has indeed been conserved. To calculate the maximum potential energy, we're going to define the difference in height. We're going to use the distance that we found earlier and the angle of the track to calculate the height, and then from the height, we'll calculate the gravitational potential energy. Now we want to compare that to the maximum kinetic energy, which we found at the bottom of the track. We're going to use the velocity we found earlier to make that calculation. We compare the two and find that, in fact, energy was conserved. We hope you find this lab useful, and we'd love to hear your feedback. Thank you.